For today's experiment, we will dispense various amounts of oxalic acid and an unknown solution into 650 milliliter beakers. Both reagents are 0.1 molar in concentration. A precipitation reaction will occur between these two reagents, forming a product that can be purified using suction filtration. The amount of products obtained will depend on the ratio of reactants in each beaker. Using the data obtained, we can then determine the empirical formula for the unknown product. On your bench, you will find two 150 milliliter beakers filled with the oxalic acid and the unknown solution, two glass burettes for dispensing the solutions, six small 50 milliliter beakers numbered 1 to 6, a suction filtration system, six weighing dishes with 6 filter papers, a spatula, a hot plate, a bottle of distilled water, and a bottle of ethanol. This video is divided into two parts. In the first part, we will go over the experimental setup, and for the second part, we will go over the data analysis. To begin, fill the glass burettes with the unknown solution. Make sure the burette is properly zeroed before dispensing the following volume of the unknown solution into the small beakers. Starting with beaker number 1, dispense exactly 2 milliliters of the unknown solution in it. If you dispense more than 2 milliliters, clean out the beaker and try again. Once you have measured out 2 milliliters of the unknown solution into beaker number 1, set it to the side and dispense 6 milliliters of the unknown solution into beaker number 2. Next, dispense 10 milliliters into beaker number 3. Then 14 milliliters into beaker number 4. Refill the burettes before dispensing 18 milliliters and 22 milliliters into beaker number 5 and 6, respectively. Collect the leftover solution from the burettes back into the original beakers. Rinse the glass burettes with distilled water and invert them with the tip up and the top cocked open. Next, we're going to add the oxalic acid into the plastic burette. Dispense the following volume of the oxalic acid into the small beakers. Start by dispensing 22 milliliters of the oxalic acid into beaker number 1. A precipitation reaction will occur once the oxalic acid mixes with the unknown solution. Continue by adding the oxalic acid into beakers number 2 to 6. To accelerate the reaction, we will heat the beakers on a hot plate. Place all 50 milliliter beakers on a hot plate. It usually takes 5 to 7 minutes for the reaction to complete. While the beakers are on a hot plate, number 6 weighing dishes from 1 to 6, and place a filter paper into each. Measure the mass of each set and record them onto your data sheet. Turn off the hot plates after approximately 7 minutes. Let the beakers cool on the hot plates for a few more minutes before setting them onto your bench. Wait a few more minutes before beginning the filtration. When you're ready to filtrate, take the filter paper from weighing dish number 1 and place it onto the suction filtration funnel. Apply a little water onto the paper, then turn on the aspirator. A suction will be generated, pulling air into the flask. Carefully filtrate the solution from beaker number 1 onto the filter paper. Rinse the beaker a few times with distilled water and transfer the rinses onto the filter paper. It is imperative that you transfer everything from the beaker onto the filter paper. Finally, saturate the filter paper with ethanol. Because ethanol has a lower boiling point than water, this will allow it to dry faster. After you have applied ethanol onto the filter paper, leave the vacuum on for 2 to 3 more minutes before transferring the filter paper with the product back onto weighing dish number 1. Proceed to filtrate the other beakers in a similar fashion. Make sure the number on the weighing bolts matches the number on the beakers. After you're done with the last filtration, set them to the side and give them a few minutes to dry. Use this time to clean up. Lastly, we will measure the mass of each set of weight dishes. By taking the difference between the set of masses and the original set, we can then determine the amount of product formed in each beaker.